Analyzing graphs of cubic functions. Here are your state standards and your success criteria. You need to be able to identify a turning point of a cubic function. You need to be able to analyze real zeros and turning points numerically. And you need to be able to explain the relationship between real zeros and turning points of a cubic function. All right, remember a cubic function is any function, any polynomial to the third degree. Your vocabulary, local maximum. The y-coordinate of a turning point is a local maximum of the function when the point is higher than all nearby points. Your local minimum, the y-coordinate of a turning point, is the local minimum of the function when the point is lower than all nearby points. Now, remember, this is the y-coordinate. A lot of times we're looking at the x-coordinate or the x-intercept, but the y-axis is your vertical axis. So when you're talking about a local maximum, like the highest point here, that's going to be your y, okay? And also, your local minimum comes from whatever the y value is of that ordered pair of the lowest point there. These are sometimes called local maximums and local minimums. As you can see on the graph, it has an arrow, which means it continues forever in the negative direction. It also continues forever in the positive direction. But if you're looking at just this window, this would be considered your local maximum and your local minimum, because this is the highest point on the graph here, and this is the lowest point on this graph here, other than where it goes to infinity. Key ideas. Your turning points of a cubic function. Turning point is exactly what it sounds like. Here the function is increasing. At the maximum, at the local maximum, it turns and goes down. So then the function is decreasing. Here's the local minimum. Again, that's another turning point. And then the function is increasing again. So it's going to be increasing, decreasing, increasing. That's something we're going to study in this lesson as well. All right, words in everyday math. In everyday life, turning points refers to a point in time or to an event that changes the course of action. So it's the same thing when we're talking about graphing. All right, your key ideas. The graph of every cubic function has either 0 or 2 turning points. All right, so a cubic function, a degree of 3, it means your highest exponent is 3, is going to have 0. So if it just comes up and kind of touches and goes up, then there's going to be like 0 turning points. If it goes up, down, and up, that's similar to this, it's a degree of 3. It has 3 zeros, but it has 2 turning points. So a cubic function is going to have 0 or 2 turning points. That's important to remember. If a cubic function has at least 2 distinct real zeros, then its graph has exactly 2 turning points. More concept summaries. Okay, this is very important to know. So your zeros, your factors, your solutions, and x-intercepts. So it says let f of x, and this is a cubic function because it's a highest degree of 3, be a cubic function. The following statements are equivalent. All right, a 0, k is a 0 of a cubic function. Factor x minus k is a factor of a cubic polynomial, f of x. A solution, k is a solution or root. Remember, root is a term we learned in a previous lesson, but a root is the same as a solution of a cubic function, f of x equals 0. So when your y equals 0, that means it is a solution. Your x-intercept, if x is a real number, then k is an x-intercept of the graph of a cubic function f. The graph of f passes through k, 0. All right, so again, these are equivalent. So you're going to see these different terms used throughout, especially when it comes time for standardized tests like the EOC. You will see these used kind of interchangeably. So those are all equivalent statements, definitions that you definitely need to be aware of. All right, another key idea, the location principle. If f is a polynomial function and a and b are two real numbers such that f of a, that's your y, is less than 0, right here. F of a is your y value, and f of b is greater than 0, then f has at least one real 0 between a and b. All right, so if you got a cubic function, it's going to pass through the x-axis. It's going to have at least 1 0 here. It could have 3 zeros if it has 2 turning points, but this one does not have any turning points, but it comes up, it goes through the x-axis and continues above. So it has at least 1 real 0. So all cubic functions is going to have at least 1 real 0 or 3 real zeros. If it has 1 real 0, it'll also have 2 imaginary zeros, which you'll learn later on. But right now we're just going to be talking about the real solutions. All right, so that was a lot of important information to get to the examples, but let's look at example 1. Using x-intercepts to graph a cubic function. Graph f of x equals 1/6 times x plus 3 times x minus 2 squared. All right, so the first thing we need to do is take our factors and find the zeros from that. So we're going to have x plus 3 equals 0. Subtract 3 from both sides. So x equals negative 3 is 1 0. And then we have x minus 2 is another factor. We can set that equal to 0 using the zero product property and find out that x equals 2 is another 0. Now we can see that this is multiplicity of 2. So that just means that shows up twice. So that would be your 3 zeros. This one and then this one twice. So the first thing we're going to do is graph those 2 points. Well, sorry, this is negative 3. I was going to say I subtracted 3 from both sides and I forgot my negative. So 0 minus 3 is negative 3. So I've got negative 3 and 2. So if I come over here and I count to the left, 1, 2, 3, that's going to be negative 3. And I count to the right, 2, and that is 2. All right, so we can't graph a cubic function with only 2 points. So let's make a table of values and see if we can come up with some more points. So we do want to choose a point to the left of negative 3. Let's put negative 3 on here because we already know it's on the graph. So let's choose, let's say negative 4 and negative 1, 0, 1. We already know 2. 2 is 0 as well. And then let's choose one on the other side, maybe 3. All right, so what we need to do is just plug the x value into the function and find out what the y value is. F of x is your y value. So again, f of x is just in function notation, but f of x is just another name for y. All right, so go ahead and plug 4 in for x here, plug 4 in for x here, and you can use your calculator to do that. Go ahead and find these y values. I'm going to pause the video and do the same thing, and then we'll come back and we will graph those points. All right, hopefully you took just a few moments to find the y values here. So let's go ahead and graph those. So I've got negative 4, negative 2, 3, negative 4, and then negative 6, 2, 4, 6. So I'm going to put a point here. And then negative 3, 0. I already have that point. Negative 1, positive 3. And then 0, 2. And then 1 and 2/3, so that's going to be just part of the way up through here. And then 2, 0, we already have that one. And then 3, 1. I bet that's supposed to be negative. Well, nope, maybe it curves in. Oh, it does go back up. So let's see, 3, 1. Okay, so something I can mention here, since the graph, you can see it's going to go up, turning point down, it's going to turn at the x-axis and go back up. How do I know that? Because this is multiplicity of 2. Because this exponent here, that means it has a multiplicity of 2. So if I were to sketch this graph, and I'm going to try to do that here in just a second, but because it turns, and one of the turning points is on the x-axis, that represents that multiplicity here. So we do have 3 zeros, but this is a multiplicity of 2. So x minus 2 to the second power is multiplicity. That's not one of your vocab words, but that is important to know. All right, so if I sketch this curve, it's going to look like this right here, except when I try to draw a curve, it's not nice and smooth like this. So I just copied this over from your textbook. Again, you guys should have access to your online textbook, but this is what the cubic function will look like. One more thing real quick. I know I'm taking a lot of time on this example, but I want to make sure that you have everything you need to graph this. So if you have a graphing calculator and you want to use your graphing calculator instead of using your zeros and plotting points in between, you can graph this even in factored form. So you can type this in exactly how it is. So 1/6 times x plus 3 times x minus 2, and then squared. And then if you hit graph, it's going to graph your cubic function. And you can see there's your 0 at -3. There's your other one at 2, multiplicity of 2. And you could go to second table and find your table of values as well. So if you have a calculator, you can do that. It's also good to know how to do this without a calculator though. But if you have a calculator, it's hard to say not to use it if that makes it easy. And as long as you type everything in correctly, it'll give you the function that you need. Again, if you do second table, that's going to give you your points, and you can scroll up and down and see -4,6 was one of the points, -1,3, 0,2. Those are some of the points that we use to graph this function. All right, example 2, finding real zeros of a cubic function. Find all real zeros of f of x. So we're only going to use our calculator to do this. So if you go to y equals, I already got this function typed in just to save a little bit of time. You can hit graph. It's normally going to be a 10 by 10, but I couldn't see the maximum and minimum, so I did change my y values to -20 and +20. Now I want to find my zeros. So my zeros are where it crosses the x-axis. So you can see this one looks like -2. That one's between 0 and -1, and that one looks like it's between 1 and 2. So let's start with the first one on the left. So second trace, and then I go to number 2, my 0. So second trace, 0, and I have to scroll all the way to the left of the 0. So the 0, remember, is where it crosses the x-axis. Hit enter, and then I'm going to scroll to where it's on the other side of the 0. So anywhere to the right of that. And then it's going to say my 0 is at -2. So let's write x is -2. And then I have to do the same process again. So second trace, I'm going to do 2. This time I'm going to find the next 0. So I'm going to have enter to the left of it, scroll below it, hit enter again. It guesses and you have to hit enter again. So 0.333 is about -1/3. So that's going to be x equals -1/3. And then there's one more 0 over here. So let's do second trace. Number 2 is 0. This time I'm going to go, I need to be to the left of this point. So I'm going to hit enter. Then I scroll above it, so I'm to the right of it, hit enter again. And it says 1.5. And that's how you would find your zeros using your calculator. Now, if it asks you to find the maximum or minimum, second trace, here's your minimum, there's your maximum, you could do that in the very same place.